In this video, we will demonstrate the config concurrency feature. Any changes that have been made that have not yet been committed exist within the candidate configuration. The config concurrency feature creates a candidate configuration for each individual user that they can edit and commit. The candidate configuration will be created for a user the first time they edit the configuration. Users do not have the ability to commit another user's candidate configuration. For example, user B has their own candidate configuration as soon as they make a change. Say user A makes a change. User B will not see user A's or any other user's changes in their candidate config until they've clicked commit. Let's begin with our demonstration. In this example, there are two different users logged into the same router, the admin user on the left and another user on the right named router read write. I will start by issuing the show user all command. From the output, we can see that the admin user has access to everything in the config, while the router read write user only has access to the one router. We will take a closer look at this later in relation to how role-based access control comes into play. For example, say you were the admin user, you could look at the pending config changes column to see if any users had any pending config changes in their candidate configurations. This column would say true if there were any pending configuration changes. Let's start by making a config change. As the admin user, I will make a change to the description of the router. Now we see the asterisk in front of the prompt, indicating that there are pending config changes in our candidate configuration. If we were to issue the show user all command at this point, we would see that the pending config changes column now says true for the admin user. Issuing the compare config command will show the user only the changes in the candidate configuration that they have made. Now I will also change the description of this same router, but as the read write user. We can see that we currently have changes in our candidate config as indicated by the asterisk. Remember, issuing the compare config command will show the user only the changes in the candidate configuration that they have made. And if the admin user were to issue the show user all command at this point, they would see that the router read write user now has true listed in the pending config changes column of the output. If a user left pending config changes and the administrator, the admin user, wanted to clean those up, they could issue the command restore config running followed by the username to do so. This clears the specified user's candidate configuration. Now let's take a look at some of the other useful commands that can be used with the config concurrency feature. As the admin user, I will issue the commit force command. This will commit only this user's changes. Now if we issue the show user all command, we can see that there are no pending config changes for the admin user. You can confirm that your changes were committed by issuing the compare config command and seeing that there are no differences. Another helpful command you can use is the show events command. In this example, we'll issue the command show events router followed by the router name, type followed by the type and subtype, limit 1 detail. By us entering type admin.running config change, this narrows the output to show us only change events for the running configuration. Adding the limit 1 argument will only output the most recent event. And adding the detail argument will show us extra information, but the information that's displayed in the output will depend on the specific event. For the type running config change, adding detail shows the actual changes made to the running configuration. This is a good command to use to see which changes were made by which individuals. Here we can see that the admin user did a running config change, and we can see the changes. This comes in handy for when you run into something called conflicts, which we will discuss in a few moments. Remember, at this point, both the admin user and the read write user have made changes to the description field on the same router, but the admin user has already committed their config and the read write user has not. When the read-write user now goes to commit their config, their single change will be replayed over the current running configuration. Their change will take effect and will be active. This will overwrite any previous changes that were made to this field, regardless of user. It is important to note that this change is additive to the current running configuration, meaning that the latest change, for example, the configuration change by the read-write user, will now exist within the latest version of the running configuration. Now, the read-write user could confirm that their changes were committed by issuing the compare config command and seeing that there are no differences. Prior to the config concurrency feature, if you were a user that only had access to a limited subset of the configuration, we did not allow you to commit any changes because there was a chance that you could commit changes that someone else had made, changes that you did not know about and did not have access to. This means that we would only let the admin user commit changes, and it would be the admin's responsibility to commit any changes that were made by users with limited access. However, the config concurrency feature, along with the use of role-based access control, relaxes these permissions by having each individual user have their own separate candidate configuration. This way, users can change and commit only the parts of the configuration that they specifically have access to. This eliminates the possibility of someone committing a change that another user made, and also eliminates the likelihood of conflicts occurring. Now we will discuss and demonstrate conflicts, although it should be noted that the config concurrency feature, along with the use of role-based access control, eliminates the likelihood of conflicts occurring. The most common form of conflict is changing a list or container object that has been removed by another user. Making a change on something that has already been removed will cause a conflict. In this example, from the admin user, I will delete a peer router. Now I will issue the compare config command to confirm that I have in fact deleted the router. Now, as the read-write user, I will make a change to the peer that was just deleted. Now, as the admin user, I will commit my changes, and this will delete the peer router. Remember, the read-write user currently has a change in their candidate configuration, where we changed the authority name for the peer router. When we try to commit this change, we will receive an error message that reads, "Failed to commit candidate configuration because another user has committed conflicting changes. The following changes have been lost. Run the compare config command to see what changes were preserved." This will show you the changes that you tried to commit but are no longer in your candidate configuration. When I run the compare config command, I can see that I have no differences because the change I tried to commit was discarded. As the read-write user, after we experienced the conflict, we could choose to put the peer back into the configuration. We can do this simply by copying and pasting the configuration. Now, if we issue the compare config command, we can see that we added the peer back into the configuration. If a user left pending config changes and the administrator, the admin user, wanted to clean those up, they could issue the command restore config running followed by the username to do so. This clears the specified user's candidate configuration. Now, when the admin user issues the show user all command, the pending config changes column will list false for the read-write user. In this example, I will demonstrate how to make config changes from the GUI. We have two separate users that are logged into the conductor GUI. The admin user has access to all three routers, while the read-write user only has access to router east combo. From the admin user, I will go to the routers menu, click on the name of the router, and then I will click on the button to bring me to the configuration. Now that I am in the router east combo configuration, I will change the description. Now, from the read-write user, I will also make a change to the router east combo description. You can use the Explore configuration on the top left and change the viewing configuration to differences to see any changes that were made. From the admin user, I will now commit the configuration. If I look at Explore config, I do not see any differences now. Now from the read-write user, I will click commit. There are very rare circumstances that could occur in the GUI which would cause certain commit failed messages to appear when you commit your configuration. Let's take a look at that now. As the admin user, I have created a peer, but now let's say I realize that creating this peer was a mistake, so I will delete it now. Now if I check the differences, I can see that this peer was deleted. The read-write user will make a change to this peer, to the description field. Then, we'll check the differences to see any pending configuration changes. Now as the admin user, we've already deleted our peer. Now we can commit this configuration. Now as the read-write user, when we go to commit the change that we made to that peer, we will see a commit failed message. This is the commit failed message that we get. It should be noted that the user would have seen a conflict if this was done in the PCLI, instead of getting the commit failure message that we are seeing in the GUI. In this case, the read-write user tried to commit and was unsuccessful. This message tells us that we are missing some elements from the peer. Essentially, what happened was that the admin user deleted the entire peer object, and then when the read-write user tried to commit their change, the peer was put back into the configuration, but only with the description field, the field containing the change that we tried to commit. That concludes this lesson. Thank you for watching. Have a great day.